Okay, in this video, we will learn how to solve a linear equation homogeneous with constant coefficient. So equation like this. A, B, C, they are constants. Okay, in the previous video, we learned how to solve those kind of equations. The first thing we need to do, write down its characteristic equation here. Okay. So by doing that, we change to solve differential equation to solve a quadratic equation. Okay. Now, so in this section, we are going to learn if we got solution for this quadratic equation, there are complex zeros. What do we do? Okay. Now let's look at an example. Y double prime plus y equal to 0. Obviously, this equation is a linear homogeneous equation with constant coefficient with a equal to 1, b equal to 0, c equal to 1. So its characteristic equation is r squared plus 1 equal to 0. This one's easy to solve. So you r squared equal to minus 1. So r equal to square roots and positive and negative square root of negative 1, which is a positive and negative I. Okay. So we get two complex zeros. R1 is I, R2 is negative I. So by what we learned in the last section, so y equal to e to the r1 t is a solution, which is e to the it is one solution, and the y2 is e to the r2t, which is e to the negative it, will be another solution. Okay. If you are happy with complex solutions, then we're done. Okay. However, we rather have real solutions. To do that, we need to use something called Euler's formula. It's like this: e to the it. I there is an imaginary number. Okay. So this one gives you cosine t plus I sine t. Okay. We're going to use this formula to rewrite y1. Okay. y1 is e to the it, which is cosine t plus I sine t. And the y2 is cosine negative t times I sine negative t. Cosine negative t give you cosine t, and the sine negative t give you negative sine t. So we got this. Okay. So by using Euler's formula, we can write y1 and y2 like this. Okay. Remember, in the previous section, we learned if y1 is a solution, so is y2. Then we add those two solutions together, it's still a solution, right? For example, we add y1 and y2. Add y1 and y2 to give you 2 cosine t. And I sine t has been cancelled. Okay. So if we divided 2 on both sides, you got 1/2 y1 plus 1/2 y2 would give you cosine t. Remember, any linear combination of y1 and y2, there will be still solution. Okay. We can easily check. We call it y3. The cosine t will be a solution. Okay. What do you need to do? Take a derivative, put it back in the equation. Take a derivative once, give you negative sine t. Take a derivative twice, you got a negative cosine t. So y3 double prime plus y3 give you 0. Okay. So we find a real solution, which is y3 is cosine t. Similarly, we can do this. We can do You can try that. negative I over 2 y1 plus I over 2 y2 would give you sine t. Okay. You can check. We call this y3. y3 is sine t. Similarly, you can check this one is also solution. So, and we can check that y1, y3, and y4 form a fundamental set. Because y3, y4, y3 prime, y4 prime, take a Wronskian of that. So y3 is cosine t, y4 is sine t, y3 prime negative sine t, and this is cosine t. Determinant of that is cosine square t plus sine square t equal to 1, which is not 0. In other words, any solution for this equation I call equation 2. All the solutions, we'll say general solution of this equation can be written C1 cosine t plus C2 sine t. We got a real solutions. So this is the general, all the solutions, we'll say general solution. Okay. Now, let's look at a general case. Okay, this is the example. So in general case, we got a y double prime plus b y prime plus cy equal to 0. Okay. Suppose, we still call the equation 1. Suppose its characteristic equation have two complex zeros. So when they have complex zero, they must be conjugate each other. So one is lambda plus mu I. Another must be like lambda minus mu I. Okay. So in this case, remember we have like y1 equal to e to the r1t. So give you e to the lambda plus mu I t, which give you e to the lambda t, then e to the mu t, then whole things times I, which give you e to the lambda t. Use Euler's formula, give you cosine mu t plus I sine mu t. Okay, like apply on the whole thing. Similarly, we can find y2 is e to the r2t, which is e to the lambda minus mu I t, which would give you, use Euler's formula, give you lambda t times cosine negative mu t, which give you just mu t, plus I sine negative mu t, which give you negative sine mu t. So again, you got two complex zeros. If you complex solutions. If you want real solutions, you would do the similar things. You can find y3 equal to e lambda t cosine mu t, and y4 is e to the lambda t sine mu t. You would do the same thing. Okay, we can easily check y3 and y4, they form a fundamental solutions, fundamental set of solutions. Okay. And they are real solutions, not like y1 and y2, they are complex solutions. So general solution for the equation 1, once you have two complex zeros, your solution can be written like this. C1 times e to the lambda t, then cosine mu t, this is your y1, okay, plus C2, y2, which is e to the lambda t sine mu t. Okay, let me say that again. We try to solve equation 1, linear homogeneous equation with constant coefficients. if your characteristic equation have two complex zeros, write in this form. So you need to know lambda and mu. You put a lambda and mu here, you find your general solution. In the other words, all the solutions will be like this. Okay, now let's look at example. Okay. So first example is your homework problem. They want us to use Euler's formula to write this complex number in this form, a plus bi. Okay. So use the property of exponential function and Euler's formula. This one can be written e to the 5 times e to the negative pi over 2i. Okay, use Euler's formula. Let me write here. Ti equal to cosine t plus I sine t. So t here is a negative pi over 2. Okay. So we got a cosine negative pi over 2 plus sine negative pi over 2i, which give you e to the 5, 0, cosine pi over 2 is 0, sine pi over 2 give you negative 1, so give you this. So the answer will be negative e to the 5 times I. So means a equal to 0, b is negative e to the 5. Okay, now let's look at another example. Okay, this example we want to solve this equation. 16y prime, y double prime, minus 8y prime, plus 145y equal to 0. And y 0 equal to negative 2, and y prime 0 equal to 1. We want to solve this initial value problem. Okay. So first of all, this equation is a linear homogeneous equation with constant coefficients. So first thing we need to do, write down its characteristic equation. So our next job is to solve this quadratic equation. This one with a big number of coefficients, it's hard to factor that. However, for the quadratic equation, we'll always can use this quadratic formula. R equal to minus b positive and negative square roots b squared minus 4ac over 2a. Okay. So our a here is 16, b is negative 8, c is 145. Since this one is hard to factor that, let's use a quadratic formula. Okay. So use a quadratic formula, you got r equal to minus b. b is negative 8, positive and negative square roots, b squared, negative 8 squared, minus 4 times 16 times 145 over 2 times 16. Okay, let's simplify this. So you got a 32 here. You got 8 plus or minus. Okay, you calculate this. You are going to find the inside is a negative 9,216. Okay. Which give you 8 plus or minus 96i, because we got a negative inside of square roots over 32. So you got a 1/4 plus or minus 3i. Okay. So in this case, our lambda here is a 1/4. Mu here is 3. Okay. remember our general formulation is e to the lambda, C1 e to the lambda t cosine mu t plus C2 e to the lambda t sine mu t. Therefore, what do we need to do? Just plug in the lambda and mu. So you got to C1 e to the 1/4 t cosine 3t and plus C2 e to the 1/4 t sine 3t. For C1, C2 arbitrary, this one would give us all the solutions. Now we're looking for specific one satisfy this initial conditions. So we need to determine what is C1 and C2 such that those two initial conditions satisfied. For example, this really is a function of t. So let t equal to 0, y0 equal to -2. So on the right hand side, let t equal to 0. E to the 0 give you 1. So t is 0, cosine 0 give you 1, and sine 0 give you 0. So we find C1 easily. So C1 equal to -2. Therefore, our y of t here is equal to -2 e to the 1/4 t cosine 3t plus C2 e to the -1/4 t sine 3t, like this. Okay, in order to find C2, we need to take a derivative of this, because we're going to use y prime 0 equal to 1. Okay, now you have two functions multiplied together. When you take a derivative, you have to use product rule. Let's take the derivative of first one. E to the 1/4 t. You take the derivative of that, give you 1/4 e to the 1/4 t. Keep the second one unchanged. Then plus. Fix first one unchanged. This one unchanged. Then take the derivative of second one, give you -3 cosine 3t, no, sine 3t. Then plus. So we find the derivative of first one, then plus C2. Take the derivative of first one, e to the, no negative, sorry about that. So take the derivative of first one, give you again 1/4 e to the 1/4 t. Take the derivative of, keep the second one unchanged, 3t. Plus C2, fix the first one. Take the derivative of second one, give you 3 times cosine 3t. Now you plug things in, let t equal to 0. This should give us 1. Okay, t equal to 0. T equal to 0. The first one give you -3/4. T equal to 0, e to 0 is 0, cosine 0 is 1. Then subtract, the second one is sine. Sine 0 is 0, so this term is gone. We don't have that. Then the third term, sine 0 is 0. So we don't have that one. We have one more, is C2. Okay, we have C2. T equal to 0 here. E to 0 is 0. Then times 3. Cosine 0 is 0. That's it. We have negative 2 here, sorry. Okay, so negative 2 here. Then you simplify this, you got 3 over 2 equal to 3c2. So our c2 here is 1/2. So finally we solve this problem. Y of t equal to negative 2, which is our c1, e to the 1/4 t cosine 3t, plus c2, which is 1/2, e to the 1/4 t, then sine 3t. So we solve this problem completely. This is our solution. Okay. In summary, if you got a linear homogeneous equation with constant coefficient, you solve its characteristic equation. If you got two complex zeros, that means you find your lambda and the mu. You just plug in here, you find your solution.